Hi, I'm an old guy and I do maths. Today we're looking at the product rule. So we're still in the area of calculus and differentiation. And what we're looking at is how you go about differentiating something that looks fairly daunting. It's usually made up of two parts, two expressions, one times the other, and the format of it is usually expressed as y equals u times v. So I'm going to show you the rule. You can see it here, but I'm going to talk you through it. And then I'm going to do an example, and by doing the example, I hope to give you a clear idea of how this works. It's designed, of course, to make life easier, and you will notice elements in here that might remind you of the chain rule a little bit, the idea of splitting something up into u and something else. The innovation here is that we also have v. Okay, so our derivative dy dx is equal to u times the derivative of v, dv dx, plus v times the derivative of u. So let's take a look at an example. And this is the simple form of the sort of thing that you will face. Not wishing to throw a scare into people, but this can also involve elements of the chain rule. So in order to find, for instance, dv dx, you might need to use the chain rule because there might be an exponent out here. Anyway, we'll come to that in later examples. So first things first, this we will call u, and this we will call v. And obviously what the product rule is designed to do is it's designed to find the derivative of this expression without having to multiply this expression out, which would not be impossible at all, and then find the derivative. Anyway, so just quickly, du dx is 10x, and dv dx is 12x cubed. Now, I hope that none of that is controversial. Right, so let's go to work. We'll get some space. Dy dx is equal to u, which is 5x squared minus 1, times the derivative of v, which is 12x cubed. So that's that part of this expression. It's a combination of that and that. And then we add to that a combination of this and this. So let's get that in here. 3x to the 4 plus 16, and we multiply that by 10x, which is the derivative of u. Now, a little bit of tidying up. So 12x to the power of 3 times 5x to the power of 2 is 60x to the power of 5. 12 5s are 60. 2 and 3 is 5. Minus 12x to the 3. That's a 3. Badly written. Over here we have 3x to the power of 4 times 10x, which gives us 30x. We can regard that as 1. 30x to the power of 5. We'll be able to combine these terms here. Plus 160x. Okay, tidy this up, and what we get is we get 90x to the 5 minus 12x. Sorry, we'll put this in frame. 90x to the 5 minus 12x to the 3 plus 160x, and that is dy dx. And that is an introduction to the product rule and a simple example of it in at work. There will be other examples. There will be other problems, and you will see how, for instance, the product rule interacts with the chain rule occasionally. And of course, our expressions may not always be as straightforward as this. This could be a sine, this could be a log. It works for all, as far as I know. I haven't encountered an occasion when it hasn't worked, put it that way. And it's relatively straightforward. It's sometimes just a bit of a grind to work through it. Thanks for watching. I hope that this made sense, and feel free to come back and look over this in case it was a little fast. Everything is in there, everything you need to know, and I'll see you on the next video. Bye.